Hello guys, so in this video I'm going to introduce the concept of how to compute a line integral, and the question is prompting us compute the line integral bounded within the region. So in this case this is a line integral on a parameterized curve, and we're given the function 2yx squared minus 4x times ds, and we're given some constraints. We're told the region is bounded by C is the upper right half of a circle centered at the origin with the radius of 5. So the first step we're going to do is simply just identify f of xy, because the formula that we're given is f of xy times dx over dt squared plus dy over dt squared times dt. So identify the function f of xy. So f of xy is literally just what's given to us. So f of xy is nothing more than 2yx squared minus 4x. For step 2, we're going to go ahead and identify our limits a and b. So keep in mind, we have to pay attention to what our constraint is. So the region is bounded by C. C is the upper right half of a circle centered at the origin with the radius of 5. So the key word right there was upper right half of a circle. So when we draw this out, it looks something like this. Pi over 2. 0 to pi over 2. So our bounds, our limits of t are 0 and pi over 2. So for step 3, now that we have our function, what we're going to do is we're going to identify our r of t. So what's our r of t? Our position vector, our r of t is r cosine t, comma r sine of t. And we know r represents the radius, and we were told that it has a radius, a circle centered at the origin with the radius of 5. So our radius of 5, which means r is equal to 5. So our r of t is 5 cosine t, comma 5 sine of t. So that's step 3. In step 4, we're going to differentiate this. We're going to get r prime of t. So our r prime of t is just basically taking the derivative of our r of t. So our r of t is equal to dx over dt, comma dy over dt. And knowing this will come handy later. So our r prime of t, the derivative of 5 cosine is negative 5 sine of t. And the derivative of 5 sine of t is 5 cosine t. So now I'm going to do a little separation line. And for step 5, we're going to identify dx over dt and dy over dt. So we do this by simply looking at what we did for r prime of t, and we know that r prime of t, dx over dt, is going to be the x component of r prime t, so negative 5 sine of t. And our dy over dt is going to be the y component of the derivative we just computed, which is going to be dy over t, and dt is equal to 5 cosine t. So now that we identified that, what we're basically doing is we're trying to set up a line integral by getting all the variables in it, so that way we can just differentiate with respect to dt. So with that, for step 6, what we're going to do is we're going to substitute x and y into f of x and f of y, because our function f of xy is given in terms of x and y. So our function was 2y times x squared minus 4x. So for x, we can substitute r cosine theta, r cosine t. For y, we can substitute r sine of t. And in doing this, we just plug in r sine t where we see y, r cosine t where we see x. In doing this, we know r sine of t, 2r sine of t, comma r cosine t squared minus 4 r cosine t. And now recall that our r is equal to 5. So we know f of 5 cosine t, 5 sine of t, will give us f of xy in terms of t, which is what we need to in order to compute a line integral. So we know 2 times r sine t, 5 sine t, and then r cosine t, 5 cosine t squared, minus 4, 5 cosine t. And that's our f of xy. So now that we have this all set up, we can move forward to compute the line integral. So what we did in the previous steps was identify all the variables. So now we're going to set up our line integral. So our line integral was going to be computed between the bounds of 0 and pi over 2. And then our f of xy, when we simplify all the constants, we get 250 times sine t cosine t squared. And you're wondering, where did that come from? All I did was simplify the constants, because remember our radius was 5. So I simplified all that. 5 times 5 squared is 5 cubed times 2 is 250 minus 20 cosine t, because 4 times 5 is 20. And then our dx over dt was negative 5 sine of t squared, plus our dy over dt was 5 cosine t squared times dt. So now we're just going to do arithmetic to try to simplify this line integral. So pi over 2 is 250 sine t squared times cosine t squared times minus 20 cosine t is equal to, we're going to distribute the square. So we know negative 5 squared is 25 sine of t squared plus 25 cosine t squared times dt. And now what we're going to do is 250 sine t squared cosine squared minus 20 cosine t, and then the square root of 25 cosine squared t plus sine squared t. And all I did was factor out the 25, because since we have sine squared plus cosine squared, but both are factors of 25, we can factor out the 25 and just leave sine squared plus cosine squared as it is, times dt. And now what we're going to do is 250 times sine t times cosine squared t minus 20 cosine t. Right here, the key step is we have to know the Pythagorean identity. Sine squared plus cosine squared is equal to 1. So it's in essence 25 times sine squared plus cosine squared is equal to 1. So it's 25 times 1. So we can substitute 1 in, and it makes this so much easier, times dt. So now what I'm doing is I'm going to pull out the square root of 25, which is 5, and I'm going to pull out the common denominator, the least common multiple of 250 and 20, which is 10. So, I'm pulling out just the 20 for the square root of 25 is 5. So 250 times sine t cosine squared t minus 20 cosine t times dt. And this is equal to 10, 250, 25 sine t. I'm factoring out a 10 times cosine squared t minus 2 cosine t dt. And now that we have our line integral set up, let's integrate it. So now that we have our integral set up, what we're going to do now is we're going to integrate. So 10 times 5 is 50. So I'm pulling out the common factor. So we can simplify this to 25 sine of t cosine squared t minus 2 cosine t times dt. So 50 times 25, when what I'm doing now is I'm simply breaking this into two separate integrals. Sine t cosine squared t dt minus 2 the integral from 0 to pi over 2 of cosine t dt. And we're going to integrate each one separately. So we're going to start with sine squared times sine times cosine squared. So what we're going to do is we're going to apply u substitution because it works best right here. We could do the trigonometric integrals, but it's easier to apply u sub, so that's what I'm going to use. So what's our u? We pick the higher power. So in this case, our u is cosine of t, and the du, the derivative of that would be negative sine of t times dt. And then we want to substitute dt back in, so we solve for dt. So dt is equal to du divided by negative sine of t. So in doing so, now what we're going to do is we're going to integrate this in terms of u. So sine of t, and then we apply the u substitution. Cosine squared is u squared times du over negative sine of t. So that's our first term. So now what we're going to do is we're going to cancel out the common signs that we have. And we're left with negative 5 integral from u squared times du. And then when we integrate this, we get negative 25 u cubed over 3. And that's the first integral. So now let's do the second integral. So now we're subtracting 2 in the integral of 0 to pi over 2 of cosine of t times dt. And what we're going to do now is we're going to plug in u back in and we're going to integrate cosine t. So negative 25 times u cubed over 3 is cosine cubed minus 2, and then the integral of cosine is sine of t. So that's our line integral. So now all we have to do is just plug in the points. So now what we're going to do for step 9, now that we have the integral, we're going to plug in the limits and solve. So recall that we have a factor of 50, and then we have negative 25 over 3 cosine t minus 2 sine of t, bounded between pi over 2 and 0. So the first thing we're going to do is we're going to plug in pi over 2. So sine of pi over 2, cosine of cube pi over 2, and then we're going to subtract it, and then we're going to plug in the 0. So negative 25 over 3 times cosine cubed is 0, minus 2 sine of 0. So what we're going to do now is we're going to go ahead and simplify this and evaluate it. So we know cosine of pi over 2 is 0, and we're going to cube that, and then minus 2 sine of pi over 2 is 1, and then minus negative 25 over 3 cosine of 0 is 1, and then when we cube it, it's just 1 cubed, and then minus 2 sine of 0 is 0. And now we're going to cross out the 0 terms, so that term zeroes out, and then this term zeroes out. And we're going to identify what we're left with. So 50 times negative 2 in the yellow brackets, and then minus negative 25 over 3 in the orange brackets. And then 50 minus 6 over 3, I'm going to have a common denominator for both of them. Plus, because minus times minus is plus, 25 over 3. And this is equal to 50 times 9 over 3. And then when we evaluate this, it's equal to 950 over 3. And that's our line integral for this example. So now in this example, we're asked to compute the line integral bounded within the region. The line integral is x plus 2y times ds. And then the region is bounded by quadrant 1 of a circle origined at x centered at the origin, and then x squared plus y squared is equal to 49. So the first thing we're going to do for step 1 is we have all these variables for our line integral. So what we're going to do, these variables right here, we're going to try to find each one of them. So the first thing we're going to do is identify our f of xy. So f of xy is equal to this formula right here, f of xy times ds of a parameterized curve, which is what that c is equal to dx over dt squared plus dy over dt squared times dt. And our f of xy is simply equal to x plus 2y. Now for step 2, we're going to identify the limits. So the key is the circle's in quadrant 1. So that's a key word, quadrant 1, which helps us identify our limits. So when we draw this out, we know that it can only be in quadrant 1. So it starts at 0 and it ends at pi over 2. And of course we know x squared plus y squared is 49. X squared plus y squared is r. R squared is 49. So the square root of 49 is 7. So that's where our radius is 7. And we know our limits are from 0 to pi over 2. So t is bounded between 0 and pi over 2. So now that we have our limits in step 3, we're going to identify r of t. And we know x squared plus y squared is equal to 49. And we know that x squared plus y squared is equal to r squared. Thus, we know that 49 is equal to r squared. So when we take the square root of both sides, r squared, and then the square root of 49, we get 7 is equal to r. So our r of t is equal to r times cosine of t, comma r times sine of t. And we know r of t is equal to, our r is 7, so 7 cosine t, comma 7 times sine of t. So that's our r of t. So for step 4, we're going to take the derivative of this, so r prime of t. So our r prime of t is equal to dx over dt, comma dy over dt. So all we're doing right now is we're just identifying the variables that we're going to plug into our line integral. So r prime of t, so the derivative of 7 cosine of t is negative 7 sine of t. The derivative of sine of t is cosine of t, so 7 times cosine of t. And that's our r prime. So now we're going to split up the screen so we can have room to write. So now we're going to identify dx over dt and dy over dt, since we need to know these for our line integral. And we know from step 4, if we identify r prime of t, dx over dt is the x component of the derivative of the position vector, and dy over dt is the y component of that vector. So we know dx over dt, we already computed it, is negative 7 times sine of t, and dy over dt is 7 cosine t. And now we're going to substitute x and y into f of xy. And because we want this in terms of t, because this is a line integral on a parameterized curve. So recall our f of xy that we identified in step 1 is equal to f r cosine theta r sine of t. And we know f of xy is x plus 2y as given to us. So f of r cosine of t r sine of t is going to be equal to, our r is 7, so it'll be 7 cosine of t plus 2 times y is our sine of t, or 7 sine of t. And that's our f of xy in terms of t. Now let's plug this all into the line integral. So now let's set up this line integral. So keep in mind that our line integral formula is f of r cosine t, r sine of t, and then dx over dt squared plus dy over dt squared times dt with respect to dt. So now we're going to plug in everything we have. So we already solved for f r t. We know our bounds are 0 to pi over 2. We know f of r cosine t is 7 times cosine t plus 14, because 7 times 2 is 14 sine of t. And then we know our dx over dt. Our dx was 7 sine of t squared, and our dy over dt is positive 7 cosine of t squared times dt. So now what we're going to do is we're going to factor out 7, and we're left with the integral from 0 to pi over 2 of cosine of t plus 2 sine of t is equal to 49 sine squared t, we're distributing the square, plus 49 cosine squared t, and times dt. So now what we're going to do is 7, 0 to pi over 2 of cosine of t plus 2 sine t. And what we're going to do is we're going to factor out the 49 inside the radical, so we're left with 49 sine squared t plus cosine squared t times dt. Now that we have our integral set up, let's go ahead and integrate this. So now let's integrate this. For step 8, we know the integral is from 0 to pi over 2, 7 on the outside. We have cosine of t plus 2 times sine of t. And inside the radical, we know sine squared plus cosine squared is equal to 1. So that's why I have a 1 there. I'm substituting the 1 for sine squared plus cosine squared. And now we take the square root of 49 and 7, and we multiply it by the 7 on the outside of the integral, and we are left with 49 on the outside, and now we're simply left with cosine of t plus 2 sine of t times dt. So now what we're going to do is we're going to integrate each term separately. So cosine of t, the integral of that is sine of t, and the integral of 2 sine of t is negative 2 cosine of t. And this is bounded between pi over 2 and 0. So now for step 9, we're going to plug in the limits and we're going to go ahead and solve this problem. So 49 times sine of pi over 2 minus 2 cosine of pi over 2 minus sine of 0 minus 2 cosine of 0. And we're going to compute these terms. You can do it in your calculator, or you can apply the unit circle, and we know that sine of pi over 2 is 1, and we know that cosine of pi over 2 is 0, so it's 1 minus 2 times 0, minus sine of 0 is 0, minus cosine of 0 is 1, times 2 is minus 2. So now what we're going to do is we're going to cancel out the terms that 0 out, and what we're left with is we're left with 49 1 plus 2, because a negative sign right here and a negative sign right here becomes a positive sign. And we know that 49 times 3 is equal to 147. So that's our line integral. So in essence, the line integral, basically you can break it down into, at least for a parameterized curve, because this is a parameterized curve line integral. What we can do is just solve for each variable and then plug it into the integration formula and then just integrate from there. And if you're plugging in bounds, you're supposed to get a scalar. Thank you for watching. I hope this video was helpful.